I am Santosh Gaidankar. Today's concept is about the static force analysis, dynamics of machine. A slider crank mechanism as shown in the figure. A force is applied to the piston. 1000 Newton a force is applied to the piston here. When the crank is at 120 degree from inner dead center, we have to determine the torque in order to stop this force. This is static force analysis. When the force is applied this side, what happens? The crank will rotate. We have to stop the rotation. If you stop the rotation, then we call it a static force analysis. Now, first, with this scale, draw the axis. I've considered this is a point. 120 is the angle of the crank, they are given it, and 200 mm is the crank length. 200 mm is the crank length. Next, and 900 is the connecting rod. Cut it out. Draw the piston here. First connect it. Piston. And the force is acting in this direction as per the diagram. F is equal to 1000 Newton, they are given it. This is the fixed link. The fixed link always given the name 1. This is second link, this is third link, and this is the fourth link. Now this is the A, this is O, and this is the B. The angle will be 120 degree. Now the force F12, F23 means 2 link is pushing to 3, F34 the 3 link is pushing to piston, and last F14. Now draw the free body diagram exactly parallel to this one. We are drawing the diagram. 2 centimeter is the diagram. We have drawn it. 2 centimeter. This link is pushing to this link. Draw a line. We don't know the magnitude here, and we don't know the vector representation, only know the direction. Next, draw the line of connecting rod exactly parallel to this one. It is 9 centimeter as per the scale. 9 centimeter is the two body diagram. Scale 1 centimeter is nothing but 100 mm for this diagram. And next, we have to draw this diagram exactly parallel to. Draw the diagram here. Draw the piston. And draw the force. The force acting this direction. F is equal to 1000 Newton. Next, now we have to write F23. We don't know the balancing force. Next, exactly parallel to this one, draw a line here. Here, force 3, 4, and this one exactly parallel to this, perpendicular to this force. In the case of piston, always it should be perpendicular to this force. this will be F14. We don't know the vector representation. We know the direction as well as we know the only direction. We don't know the vector representation, and also we don't know the magnitude here. Now with the help of this one, we are drawing the force polygon. It is 1000 Newton. Go for the scale. 1 centimeter is equal to 100 Newton, exactly parallel to this one. Draw it. centimeter. Now we know the vector representation here, this direction, and exactly parallel to these 3, 4 force, draw a line from this vector representation this side, and one more last 1, 4 from this part. Now as per the force polygon, if the arrow is this side, the next arrow should be this side, and one more arrow should be this side. That means this force F34, we have to measure it. It will be 10.2 into scale 100, you will get 1020 Newton. This will be the F is equal to 1000 Newton, and F14 we are not required for this one. Now just transfer the direction here. F34 is this direction, just transfer these directions here. Next, exactly opposite direction has to be transferred this side. F43. Now balancing vector representation should be opposite direction. Next, here it should be exactly opposite direction, F32. Now to balance this one, exactly opposite a force has to be drawn here, opposite direction. Because of this one, it is rotating now anti-clockwise. Therefore a torque has to be applied in opposite direction, T. Just extend the line here and extend this one and draw perpendicular line from this part, and this is the H here, H. Now this force is nothing but what? F12. How to find a T? T is nothing but F32 into H. Here, what is 32? Here 34 is nothing equal to F43 is equal to F23 is equal to F32. Therefore the value will be 1020 Newton. Now 1020 Newton into H is 1.5 into scale. Scale is nothing but 100 into 100. The answer will be 1020 into 1.5 into 100, 153,000 Newton mm. Convert into Newton meter, it will be 153 Newton meter. This is the solution. Thank you very much for seeing.